So let's finish up now with everything that you need to know in terms of a voltaic cell. Let's suppose that we have this as the given. Ag solid starts with Ag plus in aqua solution, and then two lines we have 2 plus in aqua solution and CD solid. So when we see this, let's first write the oxidation reaction, half reaction, which, remember what we said, that is happening into anode. So what is happening in the anode is that Ag is solid, is giving up the electron, and it's going into the solution. Okay, and then the reduction half reaction which is happening in cathode is gaining electrons. Okay. And it's becoming a solid. Okay, so when we add those two reactions together, we have to multiply this by 2 because we have 2 electrons in the cathode, or the reduction half reaction. So then we will have 2, the net reaction is 2 silver solid plus CD2 plus. Electrons will cancel out, and then we'll have 2 silver 1 minus plus solid. Okay, this is a spontaneous reaction because when we take a look at our table, we see that Ag, the reaction that is happening here, is above the CD. Okay, so it's a spontaneous reaction. We see that it's a spontaneous reaction because the electric potential of the cell, which is calculated as electric potential of the cell, which is calculated as the electric potential that is happening in cathode, minus the electric potential of what is happening in the anode, is positive. That means that is spontaneous. We talked about this even on the first lesson. So if you want to refer to that, please feel free. In our case, from the page 7 of your data booklet, what we have that is happening in cathode is positive 0.80 volts minus, that is from the formula. What is happening in the cathode, or the electric potential of the anode, is a negative 0.40 volts. And when we add those two together, we will have the potential, electric potential of the cell as positive 1.20 volts. The positive sign tells that is a spontaneous reaction, and this is how we calculate the voltage of the cell. Also, keep in mind that cations are moving on the salt bridge from the anode to cathode, and anions are moving on the salt bridge from cathode to anode. So it's pretty much is that the motion of cations is the same as the motion of the electrons, and anions is the opposite. Okay, so just keep in mind those things when you are identifying which one is anode, which one is cathode. Anox is anode is where the oxidation is happening, and red cat is where reduction, cathode is where reduction is happening. So you write the half reaction, oxidation and reduction half reactions, and then place the which one is cathode, which one is anode. Okay, so this is actually in terms of what is happening. If you want a summary, it's always start with the anode, the naming, anode, and then you have a line, and then it is the electrolyte. So what is happening? 2 plus, 2 minus, whatever. 2 plus, so electrolyte. That is as a result of the anode. And then you have 2 lines telling that you are done with anode, and you have another electrolyte that is grabbing the electrons. And then you have cathode. What is happening with electrons? They are moving from anode toward cathode, electrons, and cations are moving in the same direction. While anions are moving in the other direction, and this is happening in the salt bridge. And the electric potential of the cell, you will use the table, is whatever is the electric potential of cathode minus the electric potential of anode. This is it for Voltaic cell. Okay, I will see you to the next lesson.